Welcome Pure Maths 1 students to week 10 of our maintenance. We'll start off with a quadratics question. We have we've tried to find the set of values for k for which the line, where we've got kx is our gradient, k is the gradient, intersects a curve y equals x squared minus 2x at two distinct points. In other words, you've got a situation that looks like this. We want to, and obviously we're going to need to use the discriminant to help us with this. But first of all, let us make the curve and the line equal to each other. We bring everything across to the same side and set it equal to 0. Now, if we're going to have 2 points where they're meeting, we know that b squared minus 4ac ought to be greater than 0. So what I'll do is I'll set my b squared minus 4ac equal to 0 and find out a little bit more information. Now, one thing I might do actually, just before I go into this, is I'm going to rewrite this here. So I could rewrite it x squared, and I'll take the x out, plus x into minus 2 minus k plus 4. And now you can kind of see what we need to do here. So b squared is going to be minus 2 minus k, and we're going to square that, minus 4 times a. Now a is 1 in this case. 1, and then times c, which is positive 4. And this has got to be greater than 0. So when we expand that first bracket, we get positive 4, positive 4k, positive k squared. Minus 16 is greater than 0. Now let's just gather everything together. So we get a k squared plus 4k minus 12 is greater than 0. And if we factorize this, I'm going to get k plus 6, and I'm going to get k minus 2. And at this point, I can quickly sketch my graph because it's a positive. So we're going to have a positive k squared, so we get a negative 6 here, we get a positive 2 there. Okay. And we want, where is it greater than 0? So when k is less than minus 6, or here, where k is greater than 2. The next one, we've got to write this function into a completed square version. So first step, I'm going to take out that factor of 2. I'm just going to leave that 13 outside the square brackets. Now I'm going to complete the square inside the square brackets. Okay, so I've got to have that minus 9 there, so that when I expand my x minus 3 all squared, I end up with just x squared minus 6x. Put my square bracket at the end of that, then my 13 there. And when I expand that, I'm going to get 2 bracket x minus 3 all squared minus 18 plus 13. We'll go over here. So that gives us simplified 2x minus 3 all squared minus 5. And now the next step asks us to state the value of a for which this graph has a line of symmetry. So where is the line of symmetry? Well, 0 is less than or equal to x is less than or equal to a, where a. Okay, so we need a line of symmetry. Okay, so we know that the minimum point of our graph is at 3, negative 5. Okay, you know that from looking at this completed square version. 3, minus 5. Now, we know that on one side, we've got 0, right, at the lower end. So 0 is over here, say. Let's say it's this point here. That's at 0. Right. Well, we go 3 to the midpoint this way. So we're going to go 3 from the midpoint this way. So I think this should be at positive 6. So I think A should be equal to 6 if we're going to have a line of symmetry, because if we had it anywhere else and you tried to cut down here, it wouldn't be a line of symmetry. Okay, that's our line of symmetry there. For when a has this value, find the range of fx. Well, you know straight away that the lowest value is this minus 5, because we know what once we complete the square, we've got a minimum point. So we know minus 5 is our lowest point, so it's less than or equal to fx. Now, what's our highest point? Well, obviously, when we've got a 0 or an x as our input. So if we input a 0, what do we get? Well, I would just use this formula here. You can use this one here if you want to, but 0 squared times 2 is 0. Take away 12 times 0 is 0. So we're just left with 13. It's less than or equal to 13. And that would be our answer to that one. Now, oh, right, I was meant to do that in the next bit down. That's okay. Okay, now the next bit, coordinate geometry. We've got some coordinates, and what do we know? I'll just give myself a bit more room here. And a and b are constants. The distance of AB is 125 units, and the gradient of the line is AB. So it looks to me like we've got some sort of simultaneous equation. So gradient, let's do the gradient first. M is equal to 2, and then we can say, well, that's equal to the change in y, so b minus 2 over the change in x, 3 minus a. And we can rearrange this and say, well, 6 minus 2a is equal to b minus 2, and therefore b is equal to, what's that, 8 minus 2a. Okay, that's my first equation. Okay, now I'm going to do the distance one. So I know that the distance is equal to square root 125. So, and that's equal to using Pythagoras here. So we're going to find b minus 2 all squared plus 3 minus a all squared. Now what we can do at this point is we can get rid of our a's. So, and we can get rid of the square roots, okay? So we can say 125 is equal to b minus 2 all squared, and then plus, now instead of a, I'm going to have 3, now it's a minus a, so I'm going to go, oh sorry, I should be getting rid of my b's, not my a's. What a Larry. Okay, getting rid of the b's. Okay, so instead of b minus 2, I'm going to have 8 minus 2a minus 2 all squared plus 3 minus a all squared. Okay, now we can simplify that, so we're going to get 6 minus 2a all squared plus 3 minus a all squared. Now let's see, give ourselves a bit more room here. Okay, so 125 is equal to, now let's expand that first one. We get 36 minus 24a plus 4a squared. Let's expand the next one, plus 9 minus 6a plus a squared. Let's simplify it. I think it's equal to 5a squared. Minus 30a. And 36 is at 45 plus 45. Let's bring everything across to one side. So 0 is equal to 5a squared minus 30a. And then we're going to go, what is it, 45 minus 125, which is what, negative 80? Negative 80. And we're going to divide everything out by 5. So a squared minus 6a minus 16 equals to 0. Then we can factorize that, I think. Yeah, I think it should be minus 8. A plus 2 equals 0. And so we're going to get a is equal to 8 or minus 2. And therefore, b is equal to, now I can just take these values and chuck them up here. So that will give me negative 8 if I use the 8 for a. Now if I use the minus 2, I'm going to get 8 minus 2 times minus 2, which is plus 4, so, or 12. So these are up here, 8 comma negative 8, or negative 12 from 2. Negative 2. Alright, now what have we got? Moving right along onto circular measure. The diagram shows a circle with centre O. It is divided into two regions, R2 and R1, and by the radii OA and OB, and we've got AOB is equal to theta radians. The perimeter of region R1 is equal to the length. Okay, that's interesting. The perimeter of region R1 is equal to the length of the major arc AB. Okay, now let's look at the perimeter of region R1. You can see that it's made up of this bit, which is r theta. Now, what do we know about the radius? Do they say anything about the radius? No, they don't. So it's r theta plus this, and they're both radiuses plus 2r. Okay. Now that is equal to, according to the question, this arc length here, which arc length is r theta. So r, and this will be, now we know that if this is theta here, this one must be 2 pi minus theta. Why is it 2 pi minus theta? Because in a 360 degrees, or in a whole circle, there are 2 pi. So let's do this. We go r theta plus 2r equals 2r pi minus r theta. Now we can divide r out because r is in every term, so we can say theta plus r equals r pi. Oh, sorry, no, we're getting rid of the r's. Larry, wake up. 2 equals 2 pi minus theta. Well, we can bring the theta over to the other side, so we get 2 theta plus 2 equals 2 pi. We can divide everything by 2, so theta plus 1 equals pi. And the last thing that we need to do is just rearrange this, so we get theta is equal to pi minus 1, and we are done. Okay, now the next part of the question says, given that the region R1 is 30 centimeters squared, find the area of R2 correct to 3 significant figures. Okay, well, what we'll do here is we know that the region R1, so area of R1 is half times R squared times theta. And we know that we've been told the area is 30. So we're going to go, that's equal to half times R squared times theta. But I know, according to my previous question, that theta is pi minus 1. So I can therefore say that 30 is equal to 1/2 times r squared into pi minus 1. And now I can find out what r is equal to by rearranging. So r squared is equal to, maybe I'll do it in steps, okay, so we don't make a right hash up of it. So I'm going to double both sides, so I get 60 is equal to r squared into pi minus 1. Next, I get r squared is equal to 60 over pi minus 1, and so r is equal to the square root of 60 over pi minus 1. Now what does this give me? Bother. 60 over I'm getting the radius is equal to 5.29. Now I'm going to save that in my calculator. Now the area, therefore the area of the big part of the circle, so area of R2 is going to be half times R squared. Now we've just found what R is, haven't we, in the previous part of the question. This is R here. Oh, and we've figured out what r squared is, so all we need to do is half r squared, so 60 over pi minus 1, half times that, and then times theta. Now, the angle in this case is actually 2 pi minus theta, so it's 2 pi minus theta. Okay, so the next line is going to be half times 60 over pi minus 1 times, now, remember what theta is? It's this, so 2 pi minus pi minus 1, and then, what are we going to do there? 60 over, I know this is very convoluted, we could skip steps, couldn't we? But maybe we shouldn't. 2 pi take away pi is just pi, so it should be times pi plus 1. Now let's see what happens when we chuck this into our calculator. 0.5 times 60 over pi minus 1. I'm going to multiply that by pi plus 1, in brackets of course. Now I'm getting for this 58.0 centimeters squared. Last question of the day. We've got to differentiate this. Now my first step would be to rewrite this and say, well, that's the same as y is equal to x plus 5 to the power of 1/2. At this point we can use our chain rule. We can say u is equal to x plus 5, so du dx is equal to 1. Then I can say y is equal to u to the power of 1/2, and therefore du dy is equal to 1/2 u to the minus 1/2. Now that we know what this is and this is, we can say dy dx is equal to du dx times dy. Oh, I've made a mistake there. That's dy du. Let me just clean that up. Okay, this is dy and du times dy du, and you can see what happens. That cancels out, that cancels out. We're left with dy dx. So we'll get u to the power of 1/2, but we know what u is. Sorry, we're going to times this by this, and we'll be left with 1/2 u to the minus 1/2, and then we just insert what we know u to be. So 1/2 u is x plus 5, and that'll be to the power of minus 1/2. And if we wanted to make that look rather elegant, we would rewrite it as 1 into 2 over the square root of x plus 5, like that. Okay, and that would be fine. Oh, that's very messy up there. This is actually a half. Okay, make that a bit neater. So let me just fix that to the minus 1/2. Okay, I hope that helps you with maintenance from week 10. If I've made any mistakes or you have any queries, please let me know so I can fix it up or help you. Otherwise, God bless. See you later.